Welcome! Today we're gonna kickstart a new video series about file systems. My intention is actually to start from the higher level stuff about file systems. You know, the ideas and concepts at the more higher level, and try and slowly dig deeper into the more, let's say, nitty-gritty of file systems and components that are used in a file system. Hopefully we can even get the chance to compare different practically used file systems like ext4 or ptrfs and etc. So I hope you stay tuned and you would like these videos. The first video that we're gonna just start right now, we're gonna essentially try and answer this question: that what is the problem that we have in the first place that file systems become necessary to solve it, right? And why does it really matter to have a file system in the first place? So we have disks, right? And by disks I mean storage devices like HDD and SSDs, right? Which we all know and are familiar with. These disks store our data in raw bytes, and physically speaking, in the hardware realm, these disks, because of the way they work, they essentially group up these bytes into sectors or pages. So essentially when we say sectors or pages are kind of the baked in chunks of data within the, let's say, SSD or whatever. Now the problem is that we do save these, but there is no inherent structure to how these sectors are, for example, or let's say raw bytes are saved. Meaning that the computer cannot by any chance just magically make sense that, let's say, if we pick some chunk of data, it would tell you that, oh, this is representing, for example, a picture. It doesn't work that way, right? So the job of the file system is essentially to make sense of these, right? And I mean, it's more than that. We're going to come to it in a bit, but that's kind of the whole point of file system as a component of the bigger operating system that you're using. So before we move on to the jobs that a file system does, let's just clear up one thing. We have a concept called blocks, and by blocks we are essentially talking about the logical units of bytes. This is in contrast, or let's say this is different than what sectors are. Sectors are the actual physical chunks that, because of the way these disk hardwares work, are kind of unitized, whereas blocks are kind of the logical and the software grouping of these bytes, or let's say sectors. And usually one block represents one or more sector as a whole. And just to give you an analogy, we can think of sectors as the pages of a book. If, for example, the whole book is like our disk, the pages are its sectors, and the chapters are kind of the logical grouping of these pages, right? Which in this case would be the blocks. Okay, now that we have some understanding of what blocks are and how we logically group sectors into blocks, we can now see what the file system does, and how we can divide its different jobs. The first thing, and at the heart of a file system, lies the task of mapping file names or directory names to these blocks of ours, right? So if you save some Python file, it would, let's say, it's big enough to be multiple blocks. It's saved somewhere on the disk, and the file system takes on the role or the task to actually retrieve those relevant blocks to that file name. And you could think of the same thing would happen with directories. The second thing, which is also important, is to manage space, right? Space management. So every file system, or let's say every disk storage device, it has some free space, it has some used space, as we know. It's very important to know actually which parts of this disk are used and which parts are not. We don't want to accidentally, for example, write or overwrite into a sector or into a block that is already used, otherwise we will lose our data. And well, Another thing which is important is file system stores a lot of metadata actually, to keep track of like timestamps, keep track of permissions for a file, and also the size and many other things as well. And the last thing, which is also very important, is actually ensuring consistency and perhaps even the integrity of our files, or let's say data. The thing is that eventually, and undoubtedly, our system, our computer is going to crash, is going to have some bugs, it's going to run into some problems. We must be able to retrieve those things, or retrieve data gracefully. And there are techniques for this. Usually journaling is the main, let's say, part of a file system that handles these stuff. And it's a discussion on its own. We're going to cover that in a later video. Okay, so from a high-level perspective, the file system sits between the user applications, right, and the actual raw disk, or the raw disk blocks, right. In the user applications, or in the user space, let's say we write some file, we click save. When we click save, we use some system calls that the operating system provides to us to actually write to this place that is free and is not allocated. And that's kind of where, let's say, ext4 or btrfs captures those system calls and internally does things with them and finds, let's say, where to allocate space with the required size, to, let's say, write bytes to that disk space and save our file. And you could think of the same process happening when we want to open a file and restore something that we've saved previously. So every file system has a few basically data structures or components that are common between different types of file systems we currently have, such as Superblock, Inodes, Directories, and data blocks. Right. These are kind of like the core components of every single file system there exists. You can think of how they would look like in the disk, through this image. So usually the first block is the Superblock, which is we're just going to come to in a sec, but it's like a metadata of the file system itself. And then you have like inodes and inode tables, and finally after those we have the data blocks themselves. But it's much more involved than this. I've quite abstracted a lot. For example, we have bitmaps to keep track of data blocks and etc., but I've kind of just disregarded them for now, at least, where I want to keep things quite simple. Now, when we talk about Superblocks, as I just mentioned, they are it's going to keep the metadata or the global metadata about the file system itself. What do we mean by this? So think of this code block that I've put here. It's quite simplified and it doesn't cover every single thing that a Superblock must contain, but usually it contains, for example, the block size. So we know that in our file system a block size is I don't know, n kilobytes or n bytes, for example. And the total number of blocks, the total number of free blocks, inodes, free inodes, and so on. Even we have this magic number field in Superblocks, which specifies what is the type of the file system we're using. Moving on, we're now going to discuss inodes, which are actually one of the most important concepts and data structures in perhaps all file systems. The main job of an inode is to store metadata. The main job of inodes is to store file metadata, right? In contrast to Superblock, which stored the metadata of the file system itself, inodes store metadata of files, and in a special case, directories. And this metadata, as we just discussed earlier, it could contain size, timestamps, permissions, and there are some other flags to specify whether this inode represents a file or a directory, and so on. And then after the metadata we have some pointers actually, where these pointers point towards the actual data blocks within the disk, where we can retrieve them. and essentially an inode represents a file as a whole. And now let's consider a special case of inodes, which is directories. Essentially, directories are again inodes. However, instead of pointing towards files, or let's say data blocks, they point towards other inodes. Now these other inodes can be subdirectories themselves, so it like creates a tree of directories, or they could be inodes of files, where it would now, for example, this inode, if it represents some file, it would now point towards data blocks instead of other inodes again. So to recap, without a file system, we are essentially in a huge, meaningless, unstructured sea of bits, right? A lot of binary data which we have no idea what they are about. That's where essentially file systems come into play. At its core, it tries to make storage usable, right, and also make it reliable and safe, consistent, and like keep the integrity of files and etc. And basically, we can say that file systems provide an abstraction layer over the physical hard disk or hard drive we have, right, such that the user and the operating system can organize and data more efficiently and more conveniently. So in the next video, I hope that I would talk about how file systems store files. So basically how, for example, a file is laid out in the physical disk, how fragmentation happens, how we allocate or deallocate different parts of the disk for files, and so on. So if you found it interesting and you would like to, get more technical about file systems, stay tuned. There's more to come. And thanks a lot for watching. Feel free to leave any comments or suggestions or whatever you like under this video. I hope to see you next time.